Hi friends, here is an interesting problem. Here we are given that for a positive integer, if the quadratic equation, this is the quadratic equation, x into x plus 1 plus x plus 1 into x plus 2 plus x plus 2 into x plus 3 likewise plus x plus n minus 1 into x plus n equal to 10n. This actually is a quadratic equation. Basically, this is sum of n quadratic equations, right? This is the quadratic equation. This is the first one. This is the second one. There is the third one, fourth one. Likewise, there is the nth one. Sum of n quadratic equations. Right. For example, this is x square plus x. This is x square plus 3x plus 2. And next one would be x square plus 2 plus 3. That is 5x plus 2 into 3. That is 6. Likewise, this likewise. Okay. So we have n quadratic equations. Basically, n pairs here. Each pair will give a quadratic equation. So total we have n quadratic equations. But because this is a sum, all of them will together will form one single quadratic equation. That equation equals 10n. Has two consecutive integral solutions. The roots of that equation are, let's say, alpha plus 1. Okay, then n is equal to, then what is this n? How many pairs of these terms are there? Okay, it's a nice problem. First, let us try to break this. Instead of these pairs, let us try to break this into a single quadratic equation. Okay, so we have x into x plus 1, x plus 1 into x plus 2, x plus 2 into x plus 3, likewise. Each, there are n pairs. Agreed? There are n pairs. This is the first pair, second pair, up to nth pair. X plus n. X plus 1 is first, x plus 2 is second, x plus n is nth pair. Okay. Each pair will give 1 x square. Right. X square, x into x, x square. Here also x plus 1 into x plus 2, x plus 1 into x plus 2. What will it give? It will x square plus 1x plus 2x, that is 3x plus 2. Right. 1 into 2. What will x plus 2 into x plus 3, which is the next one? X plus 2 into x plus 3, what it will give? It will give x square plus 2 plus 3, which is 5x plus 2 into 3, 6. Similarly, in the next one, x plus 3 into 4, what will it give? X square plus 3 plus 4, 7x plus 3 fourths, 12. Okay. So, each pair will give 1x square, 1x square, that is this. There are n x squares, and each pair will give, first pair will give 1x, second pair will give 3x, 1x, 3x, 5x, 7x, 1x, 3, 1, 1x, 3x, 5x, 7x, likewise. Okay, it will give how many such numbers? There will be n first n odd numbers. Okay, we'll get 1x, 3x, we get x, 3x, 5x, 7x, such n odd numbers. What is the nth odd number? Fourth odd number is 7, right? 2n minus 1. 2n minus 1 x. Okay. So we'll get 1, 3, 5, 7, likewise n odd numbers. Nth odd number is 2n minus 1. Third odd number is what? 2 into 3 minus 1, which is 5. Similarly, nth odd number is 2n minus 5. Okay. We are getting these many x's. Now, what will be the other one? The finally we'll get for each one 1 into 2, 2 into 3, first one. In the first one, we'll get 1 into 2. 1 into 2, first one. 1 into 2, sorry. First one is 1, 1. Second one we'll get 1 into 2. The constant terms, here we'll get 1 into 2 from the second one. Here we'll get 0 into 1. 1 into 2, and the third one 2 into 3. Fourth one 3 into 4. 3 into 4. Similarly, nth one is n minus 1 into n. Okay, the constant term. First term is 0 into 1. Okay, then 1 into 2, 2 into 3, 3 into 4. So likewise, till n minus 1 into n. Those are the constant. That is this 1 into 2, 2 into 3, 3 into 4, 4 into 5. Likewise, n minus 1 into n. Okay, the first one is 0. That's why we are ignoring that. Okay. Now, this all should be equal to 10n. Okay. So, what is this? X square plus x square n terms. This is nx square. Okay. Then 1 plus 3 plus 5 plus the sum of first n odd numbers. The sum of first n odd numbers is n square. We know that, right? So, for example, sum of first three odd numbers, 1 plus 3 plus 5 is 9, which is nothing but 3 square. Sum of first three odd numbers is 3 square. Sum of first two odd numbers is 2 square. 1 plus 3 is 4. How is this? How is this? We already know, right? Odd numbers are in arithmetic progression. First one is 1 and the common difference is 2. So, there are n odd numbers, n by 2 into 2a plus n minus 1 into d. This is the formula, right? For sum of arithmetic progression. So n by 2 into 2a. The first odd number is 1. So 2 plus n minus 1 into common difference is d. Right. So then this will become n by 2 times this 2 and this 2 will get cancelled. We will be left with 2n. N by 2 into 2n. Right. So this and this will get cancelled. We will be left with n square. So sum of first and odd numbers is n square. So this term becomes n square x. This is this. Now we have 1 into 2 plus 2 into 3. Likewise, 1 into 2 plus 2 into 3 plus up to n minus 1 into n. What is this? This is equal to sigma n minus 1 into n. This is nothing but sigma n square minus n. Right, which is nothing but sigma n square minus sigma n. What is sigma n square? N into n plus 1 into 2n plus 1 by 6. We know this, right? Sigma n square formula. Minus n into n plus 1 by 2. Okay, so let's write this 6 as 3 into 2. So let's take n into n plus 1 by 2 common equals 2n plus 1 by 3 minus 1. Okay, if we take this common, then what will this become? 2n plus 1. If we take LCM, then this becomes minus 3. What will this become? 1 minus 3 is minus 2. 2n minus 2 by 3. Right. So what will that become? If we take this n 2 also common, n into n plus 1 into 2 into n minus 1 by 2 into 3. This 2 and this 2 will also cancel. So we'll be left with n into n plus 1 into n minus 1, which is n square minus 3. So n into n square minus 3 is what we are looking at. The product of the sum of product of 1 into 2, 2 into 3 up to n minus 1 into n is n into n square minus 3. Okay, which is what this one is about. N into n square minus 1 by 3. And this 10n, which is on the right side, let's bring it to the left side, minus 10n. So this is the quadratic equation that we are looking for. The simplified quadratic equation. Let us further simplify this. This n we can remove. N is common across everywhere. So the n we can cancel. We will be left with x square plus nx. One n we are removing, plus n square minus 1 by 3 minus 10 equals 0. Let us further simplify this. If we take this one, 3 into x square, 3x square plus 3nx plus n square minus 1 minus 3 times 10, which is 30. Right, this minus 1 and that minus 30 will together become minus 31. So this is the simplified equation. This is in the form of ax square plus bx plus c. Okay, a is this, b is this, c is this. Okay, now this is the simplified form of quadratic equation. Now here it should have two roots and the difference of two roots should be equal to 1. What does that mean? Alpha, beta are the roots. Alpha minus beta, modulus of that should be equal to 1. Alpha could be greater, beta could be greater, it doesn't matter. But whatever is the case, alpha minus beta whole square should be equal to 1. Okay, whichever is greater, it doesn't matter. Alpha minus beta whole square should be equal to 1. Right, alpha minus beta whole square is what? Alpha plus beta whole square minus 4 alpha beta. We can write it like this, right? Very basic algebraic manipulation. Why we are writing it like this? Because we know sum of the roots, minus b by a, and product of the roots, that is c by a. That's why we are expressing this one in this format. So what is alpha plus beta? That is minus b by a. That is minus 3n by a. That is 3. So alpha plus beta whole square is minus 3n by 3 whole square minus 4 alpha beta. What is alpha beta? N square minus 31 by 3. Right, product of the roots. 4 times n square minus 31 by 3. Here this 3 and this 3 will get cancelled. Minus n whole square plus n whole square, it doesn't matter. So this will become n square. Okay. So 1 alpha minus beta whole square is already 1 square. So 1 is equal to n square minus 4 by 3, n square minus 31 by 3. If we simplify this, this becomes 3 equals 3n square. Right, 3n square minus 4n square minus 31. Right, what does that mean? Minus n square plus 124 is equal to 3. That means n square equals 124 minus 3, which is equal to 121. What does that mean? N equals plus or minus 11. But can we take minus 11? We cannot take minus 11, right? Because n is the number of terms. 2 terms, 3 terms, 4 terms, 5 terms, whatever. Right? N is the number of terms, so we cannot take any negative value. We can take only positive value, which is 11. So 11 is the correct answer. What is the question? Then n is equal to 11. Yes, if this entire equation has got two consecutive integral solutions. Right? Very simple problem, little lengthy. We just need to understand that this is a quadratic equation. Okay, this has got n pairs of quadratic equations. First pair, second pair, third pair, fourth pair. And if we expand that, if we expand these n pairs, right, we'll get good arithmetic progressions and this product of two numbers, which again are in arithmetic progressions, right? So sum of first n odd numbers and then product of these two numbers, sum of product of numbers is what we'll get. So very basic formulas that we have to use to simplify this entire equation into a single quadratic equation. And then we know sum of the roots and product of the roots. And product of the roots is already given, which is, sorry, sum of the difference of the roots is given. We express the difference of roots as sum of the roots, function of sum of the roots and product of the roots. And we applied that condition and we got n equals 11. Right, guys? It's a nice problem. Hope you like this. Thank you.